How are you doing? Welcome to another science lesson. I'm really pleased with what I've seen with what you've done so far. And you sent some lovely little investigations and Venn diagrams and so on, comparing different creatures. What we're finding out so far is that life cycles are quite complicated, aren't they? They're not all the same. There's lots of differences, and sometimes there's very few similarities, even between species that are quite similar. So today we're going to do a little bit more about life cycles. We're going to dig a little deeper, and we're going to look at mammals. As you probably remember, mammals are a particular kind of creature. You probably remember that they tend to be animals with fur. They tend to give birth to live young, so they don't lay eggs. They have babies, essentially. So we're talking here about dogs, cats, horses, humans, those kinds of things. So we're not talking about reptiles, we're not talking about birds, we're not talking about insects. So those are setting aside today. We're going to look a bit more about mammals. And as you know, the mammal life cycle seems to be quite simple in that an adult, such as an adult horse that you saw the video of last week, gives birth to a live baby, which looks pretty much like the adult but smaller. Okay, its legs are a bit longer in proportion, but it's basically the same. And it grows, and then it becomes adult, and so it goes. So it's quite a simple life cycle. We're going to look at that in a little bit more detail today. All right, so first of all, I am going to get up my point for you. There we go. So you should be able to see this now. And I'm going to go to the very beginning. Apologies. All right, so this is part of a whole unit on living things and their habitats. And you know about habitats. You spent lots of time looking at habitats in forest school, and we'll do more of that in year 6, actually. It's one of my favourite topics to teach. And we're going to be comparing gestation periods of different mammals. Now, that's probably a new word for you. Don't worry, we'll find out about that. So, first of all, we're going to watch a couple of, one video and look at one image together. You're going to end up doing 2 pieces of work for me. I'll explain when we get there, but just as a heads up, one's going to be a bar chart and one's going to be a poster about a creature of your choice. All right. So, first of all, we know about how mammals reproduce. You remember reproduction? You'll have studied that in all sorts of ways. You studied the reproduction of plants, I think you've already done that in year 5. Anyway, so our first video is about that, and it's about that first stage of creating a new life. So I'm going to go to here, and let's have a watch of this. There we go.
Male sperm and female egg. For animal reproduction, the male sperm gets together with the female egg. The resulting fertilized cell then starts to divide, doubling each time, and turns into a baby. In humans, about 6 weeks after fertilization, the baby's heart is beating. The head, body, and eyes are also forming. By the 9th week, the baby can move. Its hands and feet are clearly formed, and for 30 weeks more, the baby continues to grow. The length of pregnancy is the time from when the egg is fertilized to the moment of birth. It's about 2 months for a dog, 5 months for a sheep, 9 months for a human, 11 months for a horse, and an amazing 21 months for an Indian elephant.
Okay, so what we're looking at then is a gestation is, as it explains here, the time between the egg getting fertilized and the birth of the offspring, the baby. So the gestation period, the time during which that baby is inside the mother in a mammal. So for humans, as you just heard, it's 9 months. That's how long it takes for a human, but it's different for different mammal species, and we're going to be looking at that. All right, so I wanted you just to check. I wanted to show you this image. So this is a picture of, it's a really nicely done cutaway drawing of an elephant, and you can see, I mean obviously it's just a drawing, but just so as you can see, look, here's the elephant baby growing in there. And one of the advantages of it being kept inside the mother and not born too soon is that the mother can move around and go to where there's food and travel to water, and the baby goes with her and is all safe inside. So the baby keeps developing in there. And if you want to go to this page, there's a link on the slide, and you can just find out, you can click on here and find out a little bit more about those if you want to. Okay, so we're going to move on a little bit. You remember on that film it said about how a dog is 2 months and a human is 9 months and an elephant is 21 months, and I might be starting to think actually there might be a bit of a pattern there. And I'm going to show you these pictures here and think, okay, what might the pattern be? So the gestation period for a squirrel, 44 days. That's not very long, that's just over a month, isn't it? 30 days in many months. Pig, 114 days. Camel, 400 days. Giraffe, 425 days. So what we're thinking there, can we see a pattern? Well, I think you probably can. I think you can see that possibly the smaller the animal, the shorter the gestation period, and the bigger the animal, the longer the gestation period. Now, I would say to you that looking at 4 different animals probably isn't enough to be sure about that, and we need to look at a lot more, and that's what we're going to do. So we're going to look at sizes of creatures, and we're not going to look at height, because you might have something that's really tall and skinny, mightn't you? Really tall and skinny, and somehow not be as big as something like, I don't know, hippo-shaped. So we're going to take weight as our unit of measurement of the size of a creature. And I'm going to give you the data. It's all here. So here's the data, here's the information. Let's just take a moment to look at that. So what have I got? I've got the type of mammal, hamster, dog, blah, 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 all of those down there. I've got the average weight of a female mammal. So the average weight of a female hamster is 0.12 kilograms. The average weight of a female giraffe, 828 kilograms, and so on. And then here we've got the gestation period, rounded to the whole week. So hamster, only 2 weeks. Quite interesting. What's the biggest we've got here? We've got the giraffe at 62. 62 weeks. It's quite a long time. All right. Here you've got instructions about what you're going to do, but I'm going to talk you through that as well, and I'm going to show you I've made a little folder of files for you. But basically, you're going to take this data, and the first thing that you're going to do is rearrange it, because at the moment it's all over the place. It goes 2, 9, 15, 14, 62, and then all of that, we're down to 4 here, and the same for weight. So you're going to do the same table again, but putting it all in order of weight. You might ask why? Well, it's because the more organized it is, the easier it is going to be to see if there's a pattern or not. And as scientists, we're often looking for patterns. You remember the pattern seeking that we did actually in at school when we were looking at patterns with picking up beads, weren't we? So this is another pattern seeking investigation. So you might remember some of the work that you did on that and use that. So what's that going to look like? Well, I'm going to get up for you the file that I've created for you to do this. And it's coming up now, is it? Oh, it doesn't want to come. I have 2 monitors, and this one, for some reason, doesn't want to try and go over. Here we go. All right. So this is what I'll put it in the files. So here's the same information that we were just looking at, and this is your instruction. So you're going to look at the information, complete the blank table to order the mammals from smallest to largest. So here's the blank table, and you're going to start with the smallest, which is hamster, and you're going to put in hamster here. Oops, better than me, no doubt. The average weight was 0.12. and the gestation period was 2 weeks. And then you're going to look for the next biggest. So the next biggest, let's do that together. 0.12, I'm looking down. These are all massive, aren't they? Big, 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 big. Oh, rabbit's not too big. Oh, look, squirrel, 0.56. So squirrel would go in here. Squirrel, I've forgotten what it was already. 0.56. And 6 weeks. All right, so you're going to carry on and you're going to fill that all in. If you don't want to do it on this Word document, that's absolutely fine. I don't mind. You can redraw the table. Whatever works for you is absolutely fine for me. When you've done that, then you're going to plot it on a bar chart. So I've put the hamster and squirrel in ready for you so that you know what you're doing. And the first job you've got to do is do the labels up here. You may remember this is called the y-axis. This is called the x-axis. So x is along, y is up. We always say along the corridor and up the stairs, x, y. All right, so you've got to label this up. And this is going to be your gestation period. So what I would suggest is that you put 10, 20, 30, 40, 50, etc., etc. Make sure that that's even. So don't put 10 here and 20 here and 30 up here. Make sure that it's evenly spaced along there. It's quite a skill doing a bar chart. And then over here, you're just going to have the names of the creatures in weight order, which is why we've got the hamster and the squirrel. And then you're going to put your bar chart. So, for example, I think you could do it in Word if you like. I really don't mind. I could do it like, it's going to be tiny, isn't it? I'm going to be doing it like that. Okay. And then my squirrel is probably a little bit too big. Or you could do it by hand, whatever works for you. All right. When you've done that, you are going to answer a few questions for me. So I've put it all as step-by-step instructions here. Label the y-axis, that's the up one, going in 10, starting at 0. That's the gestation period. Label the x-axis. I've made a mistake here. You don't need a scale there. And that's going to be with the ordered names of the mammals. Okay. Draw the bar for each animal, making sure you use a ruler. You need nice straight lines there. When they're all complete, you're going to decide if there's a pattern, and scientists call a pattern a correlation. That means there's a link between them, they correlate. So, for example, you might say there is a correlation. I think we talked about this as well, didn't we? If I said the shortest people in the school correlate with their age, that would mean, on the whole, the shorter the child, the younger they are. Now, we also talked about how that's not always true and that sometimes you can get some really tall people. And I know that you're thinking of school and you're thinking, actually, I know some people who are really tall in year 3 or whatever, and actually taller than lots of the year 5s and even the 6s. Those scientists would call an anomaly. So something that doesn't fit the pattern. So on the whole, there is a pattern. There is a pattern that links size and age of child. But there are some children who are anomalous, they're a little bit different. And I'm going to ask you to look for those anomalies in your data and try and explain them. So here we are. Are there any unusual results? These are called anomalies. Try and explain them. I don't expect it to be brilliant, but just a sentence saying, I wonder if it's this. I wonder whether it might be this that makes this one different from the others. All right. And then here, oh, another little mistake. Got a return in there that I don't need. Think of and write down 3 further questions. And you're going to send those questions to me as well. The reason being, when you've got your data, that's all very well and good, and we can say, da-da, there is a pattern, or da-da, there isn't a pattern. But then we want to look at that data and think, I wonder whether, whatever, or that makes me think that this might be, So I want you to have some little, they might start with, I wonder, little questions that you could pick out, and you don't have to answer the questions. I'm just after 3 cracking good sciencey questions. All right. We might investigate the answers to some of those as a further week. not expecting the answers. I'm just wanting your wonders, your notices. I might say, I noticed that this, and that makes me wonder whether, whatever. All right. So to recap, you are going to do for me, you're going to order the mammals in a chart like this. I don't mind if you don't even have to send me that if you don't want to, because I'll know that you've done it from your bar chart. If it's easier for you, don't send it. That's fine. You're going to send me your bar chart, and you're going to send me something about any anomalous, any that don't fit any pattern that you see, and you're going to send me 3 sciencey questions. All right. Now I'm going to go back to where we were in this. I'll put this up in the folders as well, so you can look at this, and there are some extra links. So then finally, once we've got to understand a bit more about mammals and how they normally are, I want you to choose a mammal with an unusual life cycle. So it's some suggestion here, marsupials, which you've probably come across. These are marsupials, aren't they, where they have the little pocket where the young stays in there. And all of those in Australia are in Australia, and that's really interesting in itself. Monotremes, interesting one. You probably don't know what those are, and that's fine. So you could investigate that. This is the most incredible creature. We'll talk about him in year 6 because he's so interesting. So you're going to choose one of these animals, as long as it's a mammal with an unusual, something unusual about it. I don't mind what it is, and you're going to do a little poster, maybe just an A4 sheet. It can be on Word, it can be a piece of paper, it can be whatever you like, and tell me a little bit about it. All right. So I think that's it for today. Was there anything I wanted to say? So basically, you're going to look at this file. It's got all the information there. It's got all the instructions in there of what you need to do, and it's got a graph ready for you, but don't use it if it doesn't work for you. If you want to do it in something else, I'm not fussy about that. I am fussy about using rulers though. If you don't do it on a computer, please use a ruler. And then you're going to send it to me. You can upload it to Edmodo, or you can email it. Anything's fine. Good. Hope you enjoy doing it. Hope you find it interesting, and I'm looking forward to seeing what you make of it. Bye for now.